Friends, today I saw something that was a guy had on that he had the world's most spectacular agate, and it was. I'm going to show it to you now. It's a lung. Now this was a lung that I have. I have it right here. It's a flattened out, squished lung. Now you can see the lobes of the lung and the transition metals, the different colors of the blood, the red and the black, and so forth. And this is the lung right here. Let's see if I can. You're not going to be able to see it. Let me get it in the light. Hold on a second. Alright, there it is right there. That's the lung. Now, of course it's flattened out, but you can see, I hope you can see the blood metals and, all the different stuff. This has been sitting around for years, so. Alright, I'm always talking about this little lung that I say is shock quartz. Now this is, oops, I got the wrong mouse. This is it in the microscope. Now, you can see, all the, whoops, that happens every time I start dragging and making dimensions, but you can see the shock. They think this is shock. That's not shock. That's the way the crystals propagate after the transition metals start to grow within these little alveoli, and blood surrounds the whole thing there. You see, the blood just passes by these crystals. Now these crystals make things carboxylate, and it's got something to do, it's almost like I did it again. It's almost like the catalytic converter in a car. I'm not sure of the process, but I know it comes in carbonic acids, aqueous, it goes out carbonic gases, and it comes back in gases, and it goes into the fluids of your body. So I don't know, that's the way it works. Now I'm going to show that, but it is not shock quartz. This is a lung. Trust me. And you can see all these different colors. You can see all these different shattered looking patterns. You can see all this different red stuff flowing in between it. That's the matrix of the blood doing its job to pass gases through those little membranes. Okay, so here's the lung that I say is a lung. And there's a guy that has this, and he claims his is the most spectacular agate in the world, and I agree with him. It is fabulous when I show it to you. But you can see, this is how, did it again. This is how these transition metals, they're inside the lungs, and they have a job. That's what I keep saying. We need to look at these transition metals more deeply as to how important they are in the human body. It's absolutely incredible how important they are. But this is where the blood and all the stuff flows in, and that's the main pocket of the lung, and then it disperses from there. Now here's the one I have here. Let me see, I got to get after this one, and I got one here to show. Well, it's the same one, but it's we're going to discard this. Now, this goes back, many years. It's been just laying around. Well, not many years, maybe 5 or 6. Let's see if I can home in on this and see if you can see. This is a little closer details. You see all those little crystals and everything? You see that? That's what's in a lung. Very interesting stuff. Now, I'm going to show you where the bloody patches are. You see, that's where the blood comes in. You see those little globs there? Those are agates. Blood makes agates. All different colors. They have every single different color of agate is from bodily fluids. Now, let me see if I can home it. You see it? It's all crystals and things inside your lungs. It's a little tiny lung. It got crushed. And, see that? Look at that. All right, you see the hole? There we go. There we go. You see that hole? Whoops, hold on. See that? That's where blood enters into there. You can see it. And it gushes all around there, and then it flows through, and then it starts to turn yellow and black, and all the things that happen in your lung to transfer all the different things. It's not just carbon dioxide and oxygen. It's much more complex than that. 3,500 gases, they say, carbonic acids and gases come out of here. That's what I heard. Can't prove it, but you're looking at something that looks pretty exotic to me. Now, when I show you this other guy's agate lung, you just won't believe it. But his weighs like 40 pounds or something. Big, gigantic. Oh, it's a gorgeous thing. All right, that's it for now. Thank you. All right, you're going to see a lung that it's either opalized, agatized. It's hard to say. It's sort of a fine line between that. However, it is a lung, and before I said agates were blood. Well, it's not the agates. It's garnets. Garnets create all the different bodily fluids, I believe. Garnets are from all the different bodily fluids. Anyway, this is the way that mud fossils can be preserved. Now, there's a different process. There's a chemistry that changes this quickly into perfectly preserved, almost like it just came out of the box. I mean, it's just absolutely flawless. This is invaded, obviously. The black is where the deoxygenated blood is. This is where the oxygenated blood is going to go back. It's all been invaded by other molecules, primarily oxygen, so it darkens the blood up. That's why this is normally blue in your body. And where do you see these opal lungs or agatized lungs? I'm not sure exactly. And I really got to focus in on that process because it's hard to understand. You end up with them like this. Sometimes they're just solid mud. Sometimes they're like white, stony looking stuff. I mean, it's just a million different ways it happens. It's called solvomorphism. Solvents come down through here, and they have to stay wet to be mud fossils. Once they dry out, they just turn into dust. And I'll show you this turned into dust. Gary Evans found this over a salt flat over in England a few years back. Sent me pictures on it, and I said, well, let's take a look at it. And we kept an eye on it, and a couple of weeks later, it was dust. And that's what happens to him. I mean, I knew that was going to happen. He knew it too. He let it dry out, and it turned to dust. And I'll show you the pictures. Now, a different process turns, and I think it might have something to do with kidneys and natron or something else. Preps the I don't know. I don't know. It's something is different though. Well, obviously, let me show you. All right, that's when Gary first found it, and there was a couple little things sticking out. He sent me pictures. Actually, I think this might have been the first picture he sent me. And then he wetted it, and then we watched and looked at all this change in color. But this is what you're going to see this on the outside of the lungs. And I show it on the outside of mine. There's pebble-looking things all over them. Those aren't pebbles. Those are the actual alveoli of the lung have formed silicates inside and created crystals inside these little pockets. It's the way it works. And it's very, very obvious in a minute. All right, anyway, this is Gary's lung after, I don't know, I think it was only a week, maybe 2 weeks tops. I really can't remember. But you see the blood vessels, then the blood inside of them. Then this is the darker blood. Even before it was black as it could be and red as it could be. Well, it changes. It rapidly changes as it dries out. Now, if that had stayed in the mud, 1,000 years later, you could have picked it up and it would have been just like when Gary found it. It has to stay in those conditions. In salt water, flesh, like salt water, we live in salt water. Inside of all our extracellular matrix inside of our body is salty waters. So it's not a big thing. Bones, different story. Bones have membranes around them. They don't like to be in that salt. They're protected inside of our bodies. But once you're in that flood waters, the salt invades the bone turns into transition source rock for the petroleum industry. A whole another chemistry issue there. All right, so let's take a look at that fabulous lung. All right, here's the guy. It seems like a real nice guy. Pulitzer Opal. This is from January 2018. 43 pound. But he said he ended up, I forget what he said. But anyway, here, watch. Really cool. Now, this is a dry opal. And any stone that's dry, you really don't see a whole lot of flash, you know. You need to get them wet. Now, I'm going to let it play.
would protect those from being ground flat, which would happen in a tumbler. So
let me just explain something. The way these guys deal with things, they tumble them and make them all shiny and smooth, and then you can see all the different layers of tissue. I've talked about this, about the tissues in the body are so absolutely fabulously layered. It's unbelievable. You watch when he gets it buffed up. So I'm going to let him play his little story here. Fabulous, nice guy. Here goes.
not knowing anything about it, I decided to put some hot glue on the botryoidal patterns and just cover them, keep them from being ground away by the grit. I did that mostly for the coarse grit, but
All right, you see what he did? The first time they do it, they grind the hell out of it. He's trying to protect some of these things. Let me just show you the biology, and then we'll come back to this. All right, this is about the best shot I can find. Now, these are the alveolar sacs, little holes. Air comes down, it circulates through these holes. The gases in the air exchange through the membranes through into those transition metals. Because of the transition metals, somehow there's a crystal interaction between the crystals and the gases. It ends up going into the blood, which circulates. See it, all this blood running all over? You got the black, the red, and the blue. Well, in the mud fossils, this sometimes it stays red. Sometimes it clears completely out because the arteries don't have clamps in them. The veins do. So the veins almost always stay a lot of black and blue. Well, it's always black in the mud fossils. The blue changes to black. There's the oxygen attacks it. But this is what you're going to see in this guy's lung. Absolutely amazing. So let's get back to his story here. Here we go.
afterwards I removed the
You see all these little, that's he's cutting it across on a plane. That's why you're seeing all this, but that would be like about a zillionth of an inch thick.
hot glue and continued. Well, here's the specimen ready to go into the tumbler. There it is, sitting next to the tumbler barrel. You can see the areas I've covered with hot glue. This is a Diamond Pacific, a 65 quart tumbler. At this point it was brand new. First thing that I do is put in ceramic pellets. They act as filler, and they carry the grit to make sure that all areas are ground properly. Then here I've added water and the grit, and I'm ready to tumble. So I put the rubber gasket on the top, and then placed it into the tumbler, and with a little footwork I managed to get it up there and start rolling. After 8 weeks total, 1 week with each of 6 different grits and some for a little bit more than that, this is how the specimen looked. It revealed the beautiful colors of this particular specimen. Now, I'm not saying Mexican crazy lace agate is the most beautiful agate in the world. It's probably one of the most beautiful for sure, but this particular specimen has a lot of yellow along with bright red, dark red, and white, and the overall look of this thing is striking. It's really beautiful. I was very happy that
You see, whoops, did you see all the alveoli? You see it? Now, somewhere you're going to find where this whole thing, it's probably here, somewhere there's going to be an airway entry, and there's going to be the blood entry, the vein, and the artery. All right?
thing is striking. It's really beautiful. I was very happy that I was able to preserve these botryoidal patterns. You can see I got a little bit too deep on those ones at the top, but elsewhere they were preserved pretty well. It's a really striking specimen, and I thought that everybody would want to see such a beautiful piece of stone, not just opal lovers necessarily. These thin lines of agate It's really a really very beautiful.
Now, I'm going to explain this. Those thin lines are because there's like this thick of tissue and they just skim over the top and it goes. These are membranes. These protect your body. These are the things that protect your lungs. This is what I've been screaming about. You have to have the correct transition metals. You can see, obviously, these things. Look at space, space, space. These are your membranes. They protect you. They save your freaking life. And what we do, and they are embedded with, in these layers, they are embedded with bacteria. Colonies of bacteria live in there. They live in there. They love living in your body. And if you kill them, they can't stop. They produce goo. They produce goo. They produce mucus. You get attacked, you spit out goo. It's as simple as that. You kill them, and the goo goes. The thing wants to attack you. Say, hey, the door's open. Let's go. Anyway, I can't help myself. I get into that every single time. It's the transition metals, and there's no database to tell if you're. All right, I'll leave it alone.
Full specimen. Some areas lighter than others, different darker patterns, but once again, the botryoidal patterns came out great, and given the overall intense color of this specimen, this is one of my favorite.
I mean, look at this. Look at how complex the layers of tissue are in your body. And you don't think that's different chemistry, and I don't know where your mind is at. I can't get a doctor to listen to me.
Areas. Beautiful colors, stripes. That little hole I'd like to crawl in.
You see that? There it is right there. That's the one layer. Then you splay that out and you end up with this.
Into it if I fit. Here's the final
Look at that.
specimen.
That's gorgeous.
As it has been sitting for the past 12 years or so. I've been asked how much this weighed when I first got it, and my recollection is 35 pounds. But it weighs 43 pounds now, so I doubt that that's right.
This is, I mean, what can I say? Did you see that thing? Absolutely fabulous. And there's no question what it is so long. Let me show you something. I'm going to show you a heart. You won't believe this one. And I talked to the guy. I believe I talked to this particular guy. He's, oh, you're crazy. That's not a heart. He said, that's a heart. I absolutely, positively, no doubt in the world, that is a heart. And, you know, the blue and the red, this is, something happens to them. There's some chemistry going on. And I need to find out exactly what the geology is and the origin of the solvents that are in the waters that percolate through these. Because something preserves them just as is. I mean, as is. I mean, I have them too. I have a piece of meat. Well, let me show you the piece of meat I have. But this... when they tumble it, and that's the striated layers of the heart muscle. And these are the passageways of the veins and arteries that bring the blood in to the different ventricles of the heart and supply it with blood. And I believe that's the aorta and the plumbing up there at the top. Whoops. That's... Never mind, I won't tell you. Well, anyway, I'll tell you what that is. That's a heart, but these are where these heart strings come up and invest into the heart. Look at this. This is a kidney, all right? Let me show you something. It's a kidney. They cut it wide open. Those are the valves of the kidney. It's identical to that kidney. You know, they all preserve like this in certain places. Look at how perfect that is. Let me show you a heart. All right, I showed you that first heart. There's the plumbing at the top. There's all the stuff that was around it. Of course, they ground it down, showing the muscles, and I will show you that. All right, in a couple of places, they ground across here, and you can see the stripes. So you can take a look at that. That's how this thing wraps around, and it's very strange. And one pumps out and one sucks in. All right, check this out. This is a heart, a cross section of a heart. It looks all brown, just like tissue. That's a bypass or whatever they did here. And that's that muscle that we saw wrapped around that band, that's the cross section of it, you know, and these are actually heartstrings that are in these, I showed that thing with the bump, 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 bump. That's where these things attach. See, tut, 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 tut. All right, let me show you something. That only when it turns into an opal. All right, that's an opal heart. All of these different colors are the transition metals. Once again, I don't want to go off my rails about it, but if you don't have these correct transition metals in your body in the correct amounts, you're going to be sick. And the only way they can be there is if you have the enzymes that can create them by a chemistry set made by a bacteria that live in these membranes, which are niches. It's like a fabric of bacteria. It's mucous membranes. I forget. Gil is the autopsy guy that shows this stuff in absolute, unbelievable, masterful detail. And inside these membranes that are so thin you think nothing could be in there, well, there is zillions of bacteria living in there squirting out goo to save your life. And if you kill them with antibiotics, then they will let you die. Last word. All right, now, these are the transition metals. That's the different colors. That's what you're seeing. And that is the, and now I see something here. So I'm wondering if that guy had an issue with his heart. You see that? That doesn't look right. But I'm just looking at it. But if there's any surgeons out there that see this, is this correct and is that correct? These are the two areas that I'm wondering, is this guy have an issue with his heart? Because I think they fall similar into the place where the bypass was, but I don't know. This is not my realm. Anyway, I think this is pretty cool stuff. Let me show you an eyeball in opal. I mean, it is what it is. If in the right conditions, and all this stuff I'm telling you right now is all a product, well, not every bit of it, but most of it is a product of the Great Flood. Now, after that, the same thing sort of happened, but very rarely, because this was a long duration soak in salt water, which is a preservative to soft tissues. It invades bone. The membranes that surround the bone are known since antiquity. They were called tunica, which wraps the bone. I have a bone. I might as well show it. Hold on. Here it is here. Now, this, and you can actually see the tunica because this is a mud fossil. You would never see this on a regular bone because you wouldn't see any of this. I have the cartilage. I have the actual spot where the ligament invests. I have the foramens and the all that business. Now, let's see right here. You see this triangle right here? See that? That's like a crescent roll. It wraps right around there like that. It holds, it's like a fabric that wraps around. And they all have that. It's like somebody sewed it. When the first time I saw one of these, I said, what the hell is that? Because it was like on a foot or something. I thought this guy's got a sneaker on or something. Anyway, here's what happens to the bone. You see that little, you're not going to see this. Right there. See that little big thing? That's all that's left of the bone. And that's because it gets invaded. That's what's left. And I got to tell you, the universities are letting us down. Professor Briggs down at Yale thinks that's a rock. This is very hard for me to deal with. I've got DNA and everything, and they just reject it. He says it's all nothing. Anyway, I'm going to let that go too. All right, Mudfossil University, the last place on the planet. Truth is allowed and required. Around here somewhere, but it's well, I mean, it's a mud fossil rock. It's flesh, and this little flap here. You see this flap? That's called the fascial tongue. This takes this chunk of meat and it locks it in. Of course, it's upside down. Locks it in to another organ or piece of meat or a muscle or whatnot. And I will show you this in actual living tissue. And here it is. There it is right there. It's a fascial tongue. I sat through a lot of autopsies, my friends. There's some good, strong looking eyes. We got some muscle attachments to our eyeballs. You heard of the evil eye. Well, this is the opal eye. Yes, that's the muscle. What can I say? Obviously, the green turns into the muscle-ish thing on this particular one. And again, it's all what percolates down through the soils, in through these tissues and invades. And there's some chemistry I haven't figured out yet, but I will. And if I showed you some of the things that are on the planet, I don't know, you'd have to be sitting down. Anyway, I will. You're going to see it. All right, Mudfossil University, again, truth is the only thing there is.